Alright guys, good evening to you all. I believe you all are doing fine. Alright. It seems you guys are waiting for me. Wow, Jesus Christ. So first of all guys, what you do for me? You'll see me very soon. You see me very soon. I'm back in my camera. Take this link of this live right now and send it to any group you have. Because we can't just be this number we're having now. We are supposed to be very, very many. So do that and also give this video a like because we're doing a lot tonight. Okay, so let's say it goes. We should be up to 1,000. It's very possible. Share this live, guys, to every group you have. Let's start. There is no time. Make sure you give this live a like. Like this live. Don't just watch without liking. I'm waiting. We have to get to a certain number before I start. Guys, what are you waiting for? What are you guys waiting for? Let's go. Alright guys, I'm here. I know you guys have been waiting for me to come. Now I'm here. So let's see how it goes for the Jamb 2025 examination. First of all, I want to congratulate you all for the success of your exam. Even if you've not written it, it's already a success you get. So it's just about putting more effort. It's almost time for the exam. The exam is starting 24th, you get. So I wish you all success in the exam. You understand? So let's see how it goes. Let's see how it goes. So first of all, we talked about chemistry. I just thought of this key area to talk about. That's why I decided to come here to quickly organize this slide for you all. It is on what we call electronic configuration. Everybody pay attention. Electronic what? Configuration. Before I even talk about electronic configuration, there are key things I have to talk about. Everybody hold on. There are key things I have to talk about. Now everybody, so this is like a revision class you get. This is like what? A revision class. I'm coming guys. Alright, let's go. Electronic, or let me just quickly go straight to what we have today. You get, I believe you guys have been watching videos on YouTube to learn different aspects. So let's say it goes electronic configuration. So there's a first question I want to ask us. What do we use to write electronic configuration of atoms in chemistry? What do we use? It is simply what we call electron. Don't get this wrong. You can see from the spelling electronic, I've seen electron, I've brought out electron from it, which you can see here, everybody. You get. So everybody listen very well. Listen very well. Remember, in introductory chemistry, let's play with some things for your JAMB exam. What are the components of an atom? Please tell me, what are the components of an atom? What are those subatomic particles that are found inside an atom? Everybody tell me in the comments. Tell me. What are those subatomic particles? What are they? I call them PEN, P-E-N. What are they? Protons, electrons, and neutrons. I believe you are aware about that. Protons, what? Electrons and neutrons. I believe you are aware about that. These are the subatomic particles that are found inside an atom. And before we even come into this, let's just play with all of these things. You know, now, these subatomic particles, they have charges. Protons generally, I believe everybody is aware that protons are positively charged, whereby electrons are negatively charged. That plus VE means positively charged, minus VE means negatively charged, and then neutrons are neutral. You understand now? But I want to quickly talk about where I'm here, you get, because it's very important I talk about this thing. But if time permits, we're going to talk about so many aspects in chemistry. So guys, so as I was saying, listen very well. So what do we use to write electronic configuration? It is what? Electron. You can see it. Now listen. Listen very well. So now, let's quickly solve a question. Even if you don't know it before or you know it, just relax. Everybody will get to understand it very well as we progress. So now here is a question. This is Na, here is 23, and here is 11. This is an atom. This is what? An atom of sodium. This element is what? Sodium. Now, in introductory chemistry, if you watch some of my video lessons here on YouTube, I've talked about how we can how we can determine the numbers of protons, electrons, and neutrons in atoms. Now, you should be aware that atoms can be of two types. Atoms can be neutral, and also atoms can be charged. Atoms can be neutral, and also atoms can be what? Charged. Relax, relax, and relax. Alright, so now I'll be using here to quickly do the explanation before we solve this question. Relax. This is an atom X, and this is another atom X. I believe everybody can see this part of the board. This atom that is X, I represent it as A and here as Z. Same applies to this A and here as Z. There are two different sets of atoms. Relax. Remember I said that, okay, they are atoms. Both of them are atoms. Atoms, atoms, atoms. You get. They are atoms. Alright, this is not parts. Now, if you observe, they are the same, but I want to differentiate them. This one is having plus or minus sign. Wow. This one is having plus or minus sign. What, whenever I see plus or minus, it tells us that, oh, that thing is charged. So, this guy actually is an atom, I'm aware, but it is a charged atom. Everybody relax. This one that is just an atom without any plus or minus, you can see that there is no plus, there is no minus. Then, this guy is a neutral atom. Everybody take it easy. We are going to progress. All what we are here to learn tonight, we'll learn them. You get? Now guys, make sure you like this video. Make sure you like this video. Make sure you share these links to your friends. Don't just watch alone. You've seen opportunity to learn. Share with your friends as well. So then, you can see the two types of atoms. You relax, I will explain. Now, because I don't want to write the board, that's why I'm just trying to, write everything carefully on the board. So A and Z, they mean something. Are you there? A and Z means something. I will not say this, I will not write this, I'll just say it with my mouth. It's simple now. What's A? A is called atomic mass. What is A? A is called what? Atomic mass. If I don't call A atomic mass, I will call A mass number. If I don't call A atomic mass, what will I call it? Mass number. So you've learned two names for A. Then what about Z? Z is called atomic number or proton number. Relax, relax, relax. Let me wipe. I need space. I need space. So let's say, for instance, we want to learn, not for instance, we are learning now how to calculate the proton, electron, and neutron number for this set of atoms, both for this neutral atom and also for this charged atom. How do we do it? Everybody relax, Relax. Let's take it step by step. I will have to just elongate this one, make it big, so that we'll see what's happening. So this is X, here is A, here is Z. This is another X, here is A, here is Z. You get. So then, this one I have plus or minus, hence it is charged. This one is a charged atom. This one is a neutral atom. You get. Whereby this one doesn't have any plus or minus, so it's neutral. So what we are learning now is how we can calculate for the proton, electrons, and neutrons for both of them. How we can calculate for the protons, electrons, and neutrons for both of them. Everybody relax, we are going to walk through all this. So now, how do we? Now I've given us what A and Z mean. For those who are just coming, A, Z, they have something, their names. A, look at A's name, atomic mass or mass number, whereby Z is simply called atomic number or proton number. Are you there? These are the possible names for A. Relax, relax. How do we get our proton number? Now let's calculate for our proton, electron, and neutron number for a neutral atom. An atom without any charge. What did I just say about how do we get our proton number? Our proton number is what we are having down, because I just explained to you that proton number is same as atomic number. Proton number is same as this thing that is down. So proton number is Z. I believe it's clear. Proton number is what is down always. So what is down, for instance, let's say it's 11. What becomes proton number? 11. Let's say, for instance, what is down is 1 million. What becomes proton number? 1 million. Are you there? But now you have to note this. For a neutral atom, you must take note of this. Your proton number is always equal to your electron number for a neutral atom like this. So, since my proton number is Z, so my electron number will be whatever is my proton number. So both of them equals each other. So electron number is my proton number, and proton number is what is always down. So lastly, let's calculate for neutron number. How do we get it? Because we need all these things in electronic configuration understanding. How do we get our neutron number? To get our neutron number is simply by minusing what is up with what is down. So neutron number is simply A minus Z. I believe you are following me. Neutron number is simply what? A minus Z. That's neutron number. That's what? Neutron number, guys. That's how we get what? Neutron number. You get A minus what is up minus what is down. So let's quickly let's quickly do the same for this our charged atom. You get, proton has a charge. So how do we get our proton, how do we get our electron, and how do we get our neutron? Very simple. The only thing that changed is calculating electron. These other guys did not change. What we are doing here is what we have to do here. Now, now the meaning of A and Z is still the same for the meaning of A and Z here. You get, so it doesn't change. So then, what's my proton number? My proton number is whatever is down. That's why it's Z. Now, neutron number, same approach, A minus Z. What is up minus what is down? You get. But now, this must be noted. For a charged atoms, you know, an atom that is charged can either be positive or negative. If the atom is positively charged, then it is called a cation. And cations generally are ascribed to metals. Metals are positively charged generally, whereby anions, if this atom has a minus charge, then it is called an anion, and anions are what? Non-metals. Hope you are aware about this. So all this must be noted. So now, moving further, what do we do next? How do we get our electron number? Very simple. For we to get electron number, it's done by this formula, which is proton number, no space around number. So just a proton number minus your charge. Relax, we'll solve questions. Proton number minus your what? Charge. Proton number minus your what? Charge. Proton number minus your what? Charge. So all these must be noted. All these must be what? Noted. So now, guys, let me write this. Let's tackle questions. Everybody relax. This is Na, sodium, Na23. As I said earlier, 11. So let's calculate the Pn together. So everybody looking at the board, looking at this sodium. Is this sodium charged or neutral? Are you seeing any plus or minus? Look at it very well. Tell me in the comment section, is it charged or neutral? It is neutral. There is no charge. Then I'll use this approach on what I explained. That's what I'll use to solve it. And what did I tell you guys? Based on the, oh my God, there's something I did not tell you guys. Please take note. Did I say it? For charged atoms, so proton number is not equal to electron number. Did I say that? For charged atom, proton number is not equal. That's why I said equal to and slash. They are not equal. Don't go and write that. Since my proton number is so number, electron number should be so number. Should be same number for each. Don't try that. For a charged atom, your proton, electron, they are not the same. Don't worry, you see the reason why I'm saying all this in when we come to electronic configuration. So guys, what do we do next? Very simple. What do we do next? How do we get our proton number? This guy is neutral. So we use the neutral concept. And I told you, proton number is the down number. It is literally what we're having down. So it's 11. Since it's neutral, proton number is equal to electron number. So they are the same. Electron number is 11 as well. So then what do we do next? Neutron number, what is up minus what is down? A minus Z. So neutron number will now be A minus Z. What's A? 23 minus Z, 11. 23 minus Z, 23 minus down, 11. So neutron number will now be 12. Class, is it understood? So the proton, electron, and neutron is 11, 11, 12. 11, 11, 12. Class, is it understood? Class, is it understood? Let me know. Is it understood? Let me know in the comments. So we progress. Is it understood? Let me know in the comments. So we progress. Is it understood? Let me know in the comments. So we progress. Very good, guys. Guys, you guys are not even liking this video or even sharing this live. What's happening? You guys should share it. You guys should share. You understand? Share it, share it, share it, share it. Like the live, share this live with your friends in various groups. Don't just watch alone. Share the live. Give this video a like. Like this live, guys. So now, what do we do next? You can see we've tackled the one for neutral. Let's tackle the one for charge. They are all simple. For those persons joining, don't worry, it's a live video. It will be saved. It will be saved. So you can have access to it again. So this one now, looking at this guy, you have to be very careful. This one now you are seeing is another sodium, but this time around, this sodium has a charge. The charge is +1. Then is a charged atom. I'll use this approach. My proton number doesn't change, is what is here. So it's 11. Can I say my electron number is 11? Can I say that? No, because it's not have a charge. Then I will use my formula, which is proton minus charge. What's my proton number? Alright, proton minus my charge. So electron number, what's my proton number? 11 minus my charge. That your charge, put it inside a bracket. And what's the charge here? +1. Your charge is not 1, no. Pick everything. +1. So minus +1. Close the bracket. Electron number equals 1. Now you must be aware that when minus times plus, bracket means times. When minus times plus, what do we have? Minus. When minus times minus, what do we have? Plus. Hope you know this little math. So then, this is minus times plus. And what is that? Minus. So 11 minus 1 in general, and that is 10. So your electron number is now 10, whereby your neutron number doesn't change. What is up minus what is down? 28 minus 11, and that is 12 for neutron number. Class, is it understood how we got the proton number, electron number, and neutron number for this charged atom? Please, we need to learn all these things, eh? Guys, like this video. Don't just watch without liking. So, that is for that. That is for that. So you can see the approach we've used. I'll be giving you guys your own question to tackle now. Your own question to tackle based on my explanation. They are not hard. I'll be wiping the board right now. It's just because you came. Don't worry, just relax. You watch it again, definitely you get it. Just relax. It's not hard. So, for those who started this life with me, these are the questions you'll be solving. Solve for this is 40, this is 20. So you solve for the proton, electrons, and neutron in this atom, calcium. After you solve for this, you solve for this one, aluminium Al3 plus 2713. You solve for the proton, electrons, and neutrons as well. I'm just giving questions to tackle and practice. Do you understand? It's not hard. It's not hard. All these things are very simple. They are very simple. They are very simple. They are very simple. So class, for those who are just joining, they might find it difficult. It's not hard. I don't want to even say the word difficult because it's not hard. It's not hard at all. It's not hard. Very simple. Guys, make sure you like this live. Share this live as well. So, I believe over 80% of us here understood what happened, because it's based on what happened now, what has happened, will help us understand what I want to talk about, which is electronic configuration. With this alone, I will solve a lot of questions. So everybody take it easy. Let's progress. So I'll be wiping the board so that we can just start through the electronic configuration. And as I explain and solve questions, I will still take it back again so that you guys will be able to get everything very well. So for those guys who solved, you got it right. So let's take it again. Let's start with the electronic configuration aspect. Let's start with the electronic configuration aspect right away. So now, electronic configuration. Look at everybody. You have to be careful. Electronic configuration. So there's a question I want to ask us now. For those who started this live with us, I told you guys something. What do we use to write electronic configuration of elements? What do we use? Out of the three further subatomic particles which we talked about now, protons, electrons, and neutrons, which one do we use? Electron now. Are you not seeing electron from the word electronic? So we use the electron number to determine what? Electronic configuration. You understand? We use the electron number to determine what? Electronic configuration. Then, how does it work? Everybody, how does it work? Relax. Relax. To write electronic configuration, you must understand a principle in chemistry called the Aufbau's principle. You must understand a principle in chemistry called the Aufbau's principle. The Aufbau's principle has another name in case you are asked. It's also called the build-up principle. What does this principle talk about? Relax. I will draw the diagram for this principle. Alright, those things you used to see in your chemistry when you're in secondary school, I'll draw the diagram now. It is, relax, 1s, 2s, 3s, 4s, 5s, 6x, and 7x. Alright. I know you're not wondering, where is this s coming from? That's why you must understand quantum number as a topic. So if you are here finding it difficult to understand that aspect of chemistry called quantum number, at the end of this slide, go watch my full video lesson on my channel that explains on quantum numbers, but we explain. In the topic quantum number or in chemistry, we have different types of orbitals. Are you there? We have what? Different types of orbitals. These orbitals include the s orbital, the p orbital. Alright, let me write it very big. These orbitals include the s orbital, the p orbital, the d orbital, sp,d,f, the f orbital, even the g and h, but I'll stop here. So everybody be aware and take note of these orbitals. We'll be using it a lot in this aspect. So on this principle, it talks about what I'm just listen. So now I've written 1s to 7s. I will now go for, I'm done with s orbital, let me go for p. For me to go to p, I'll reduce the number. You know I start from 1, but for p, I will start from 2. So it can be 2p, are you there? 3p, 4p, 5p, 6p, and 7p. Are you there? I just see what I've done for p orbital. I'm done with p orbital. Let's go back to d orbital. So I will now reduce it again. You now reduce it for p. For d, I will still reduce it again and start from 3d. 3d, 4d, 5d, 6d, and 7d. You get. For f, I will reduce it again. So it's going to be 4f, 5f, 6f, and what? 7f. So now, after we've successfully drawn for all these orbitals, I will now start using lines to bring them down. There is a reason. You will see the reason very soon for me doing these things. So everybody pay attention. It's not hard. It's very simple. Everybody pay attention. It is not hard. It is very simple. 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 Now, what do? Everybody pay attention. You can see the lines I've drawn. So these lines helps us to write the electronic configuration for elements properly. Relax, let's use that same sodium we're talking about, Na. There was 23 and here is 11. So everybody now, I believe now we are familiar with how we can quickly get our proton, electron and neutron number for atoms. So you looking at this atom, let's quickly calculate our proton, P and 10. Remember, proton is what is down always. So proton is 11, electron is, now since the neutral atom, proton electrons equal. So then my proton electron are the same, then I'll put 11 here as well. So for neutron number, how do we calculate neutron number? What is down minus what is up? So 23 minus 11, and what is that? Neutron number is what? 12. For class, what do we use? What do we use to write electronic configuration of elements? What do we use? Is it proton or electron number? Electron number. I know now, I'm saying they are the same now. Why am I even stressing myself to, tell you guys specifically that it's electron number? You will see the reason very soon. Don't go and use something else. It is always electron number that you use to write electronic configuration. There is a reason. There is a reason. So what becomes the electronic configuration for this sodium? We'll start. And I will write electronic configuration as EC. Do you understand? I will use the acronym EC. Electronic configuration is equal to, for sodium, using electron to be 11. We'll start with this thing. Now, all these orbitals you are seeing contains electrons. All these orbitals contains what? Electrons. I'll be writing out the maximum number of electrons these orbitals can take. For S orbital, the maximum number of electrons it occupies is 2. For P orbital, the maximum number of electrons it occupies is 6. For D orbital, the maximum number of electrons it occupies is 10. And F orbital is 14. If you check the difference is 4. But leave that alone. The most important thing is for you to know the maximum number of electrons these orbitals occupy. So now, for we to write electronic configuration, we start with this one first. After 1s, you go down. After 1s, what's next? 2x. After 2x, what do you do next? Will you go to 3s? Don't try that. You can see it's coming down. So start from 2p first before you go to 3s. Is that understood? After 3s, what will you do? Is the 4s or 3p? 3p before you go to 4s. After 4s, what do you do next? 3d, like that, down. So what do we do next, class? It's going to be for sodium having electron number to be 11. What do we do? For sodium having electron number to be 11, what do we do? You'll see it's very simple. So now, class, listen. Electronic configuration for sodium having its electron number to be 11. Like I told you, it is the electron number we use to write electronic configuration. We'll start with the first, which is 1s. But for the s orbital, what's the maximum number of electrons it takes? 2. So 1s, 2. Do you understand? What's the next? 2s. The next is 2s what? We are still on the s orbital, so it's 2s2. Are you there? Now, when will I stop? I will stop when I get all these numbers to be 11. When I add them and I give me 11, I will stop. That's where I will stop. So then, 2s, what's next? Is it 3s or 3p? Or 2p rather? 2p. So here becomes 2p. But for the p orbital, what's the maximum number of electrons it takes? 6. So I'll write 6 like this. Is it up to 11 for the electron number for sodium? 2, 6. 2 plus 2, 4. 4 plus 6, 10. It's not up to. So then we write for 3s, but we stop here. So we'll go back to 3s. So 3s. I know s orbital carries the maximum of 2, I'm aware. But now, because we are writing for that particular element, we know it's 2 initially, but we will now write 1. Why? Because we have 11 for our element we are looking for. So 2 plus 2, it is 4. 4 plus 6, it is 10. 10 plus 1 is 11. So this forms the electronic configuration for sodium. Class, are you there? There is a reason. No, I want to change the question now and give you guys something else. I want to change the question. Don't worry, at the end of the live, the video will be posted. It will be uploaded on YouTube. So there's no problem, guys. Everybody just relax, Everybody just relax. Meanwhile, as earlier said, make sure you share these Life, if you are watching right now, you've not liked it. I don't know why you are not liking it. Share this life with your friends, guys. Share this life with your friends. Like this life as well. You get. So I believe over 80% of us here understood this. So now let's go higher. Let's solve another type of question. It's very simple, guys. They are all very simple. They are all very simple. I want to wipe this question. I want to wipe it. I want to wipe the question. And even the answer as well, because for those who are just joining, don't worry. At the end of the live, the video will be saved automatically on YouTube, so you can have access to it. So then, this is another element or atom we want to write the electronic configuration for. You have to be careful. Now, look at sodium. This is another sodium, but this time around, this sodium has a charge. It has a charge. Look at it now. This sodium has a charge. You have to be careful. That's why I taught you guys first how you can get the proton number, electron number, neutron number for atoms. You get. So let's quickly do for this sodium based on those who started with us from the scratch. Or if you are just joining, you just relax. You watch it as soon as we end the live. But if you can quickly just get it, it's very good. Try to get it. I will still explain and make sure you get it. How do we get proton number? Proton number is always what is down. So 11. But for electron number, remember, for a neutral atom without any charge, I told you guys that proton and electrons are the same. So if it was a neutral atom without any charge, here would have been 11. But now it has a charge. That's why I must use the formula which I gave to us, which is proton number minus charge. You understand? So electron number, what's my proton number, class? What's my proton number? 11 minus my charge. Your charge is given there. Put it in a bracket. Don't stress yourself. Minus your charge, which is plus 1. Close the bracket. And I've explained to you guys that minus times plus. Minus times plus is minus. Whereby minus times minus is what? Plus. You understand? So that is for that. So electron will now be equal to 11 minus 1, and that is 10. So electron in total is 10. Neutron is what is up. For those who are just joining, to get neutron is what is up minus what is down. So 23 minus 11, and what is that? 12. So then, class, everybody listen attentively. Remember, to write electronic configuration, what do you use? Electron number. To write electronic configuration, what do you use? Electron number. To write electronic configuration, what do you use? Electron number. Then you come here. Electronic configuration is equal to 1s2 based on this. You write for this one first. I told you guys, for those who started with us, 1s2, 1s2. What's the next? We're writing for 10. Oh, what's the next? 2s2. And why am I putting 2 for s? Because the maximum number of electron s orbital can take is 2. But for more understanding on this topic, go watch my video lesson on quantum number to learn it very well. So then, after that, what's the next? After 2s, what's the next? 2p. So then here becomes 2p. And what's the maximum number of electrons that take? 2p6. Class. Now let's count. 2 plus 2 plus 6. That's 10. We've gotten it. Because I told you, use your electron number to write electronic configuration. Should I progress and I write for because some people will be like, why not write for 11? No. You use electron number to write your electronic configuration. This is what I want to actually make you guys understand, because they bring it normally in the Jamb exam. Class. Is this understood? Let me know in the comment. Let me know in the comment. Is this understood? What we just did now, because I'll give you one practice question. I'm going to give you guys your own practice question right away. So everybody, let me know. For you, if that because you are just coming, for others, I believe you'll get it very well, because you start with us. For other persons, because you know me, I don't like the fact that when I ask question, me asking you, do you understand? I want a positive response, because I know that without explaining it, there's no way you won't understand. So for those ladies saying what they are saying, I don't have to go say it. I don't like to say that word. Then watch this video from the beginning again as soon as the live ends. You understand? Don't pressure yourself. Relax, Relax. Take it easy. So guys, what do we do next? What do we do next? There are other things to learn, other things. I will teach you some things. Relax, everybody, I believe everybody have assimilated this. Let me give you your own practice question to solve. Let me give you guys your own practice question to master this aspect of chemistry. Let me give you guys your own practice question to master this aspect of chemistry. Alright, So here is your own aluminium Al3. Here is 27. Here is 13. You write for the electronic configuration for me. Write the electronic configuration for me for this, and also write for this one again. Al, alright, 27 plus 3 and then 13. You still write for the electronic configuration for me. You can see that they are the same element, oh, but one is neutral, the other is charged. Don't come tell me it's the same thing, no. I've explained. I've explained. I've explained. Victor Charles. Victor Charles. You think I don't see what you're saying? Alright, guys. Alright, guys. So now, guys, what do we do next? There's something I want to learn. There's something I want to learn very, very fast. Guys, make sure you like this video. Make sure you like this video. Make sure you like this video, guys. Make sure you like it. Share with your friends. Take the link right now. Share it to your WhatsApp group. We have to get to 500 watching this live right away. Guys, go and do it now. Before I progress, quickly go and do that. I've said, Go and do it. Go and do it. Share it to your live. Tell your what do you call it? What do you call it? Your just share the live. Share the live. Make sure you like this video. Share the live. Like this video. Share the live. Like this video. Yeah, like this video. Share the live, guys. Share the live. Like the video. Share. Take the link of this video now. Send it to your various groups for them to learn what you are learning right now. So, guys, what do we do next? There's something we want to do that the Jamb exam always asks as well. So you should pay close attention. You should pay close attention. So people are already solving the question. That's very good of you guys. So now on to wipe. So we can learn other things under this aspect. We can learn other things under this aspect of chemistry. And the next thing we want to learn is how to determine the number of unpaired and paired electrons. How to determine number of unpaired and paired electrons. Everybody relax, I will explain. How to determine the number of unpaired and paired electrons. Very simple, like ABCD. The Jamb exam, this is how the question will come. They will give you the electronic configuration of the elements. Let's say, like I'm a Jamb official. This is the question. The 1s2, 2s2, 2p6. Let me just say 2p3. Let me stop here. Now, I believe you watching me now understood how all these things was gotten. Because I have to make sure I take it step by step. Before I can even come here, I have to teach you guys how to do something like this, how to write it, and you guys can write it. But now, we want to learn how to determine number of paired and unpaired electrons. Very simple. Very simple. To do that, what do you do? To do that, what do you do? That's the question you ask yourself. What do you do? Very simple, guys. You simply look at the electronic configuration they gave you in the question, and your eyes should go to the last orbital. Remember, all these things are orbitals. This S is an orbital, this other S is an orbital, this P is an orbital, as stated here. All these are orbitals, the S, the P, the D, F orbital, they are all examples of orbitals you get. So S, S, P, all of them are orbital, but your eyes should go to the last one, always, for you to get the number of unpaired electrons. Are you there? For you to get the number of unpaired electrons. For you to get the number of what? Unpaired electrons. So, what do we do next? You just pay attention. Then, alright. So, this must be noted, guys. You must note this, that for all these orbitals we are having here, that's why you must watch my lesson on quantum number. I've explained everything. But you must be aware that all these orbitals, for the S orbital, for the P orbital, for the D orbital, the F orbital, we have number of boxes we draw for them. Please just note it. All these things, they are reasons. For the s orbital, we draw one box. I know the reason, but just memorize it for you to learn this aspect. For the s orbital, we draw what? One box. For the s orbital, we draw what? One box. For the p orbital, we draw three boxes. Just note what I've said. For the s orbital, we draw one box. There is a reason, but just note it. For the d orbital, I talked about p. We draw how many boxes? 3 boxes. For the d orbital, we draw 5 boxes. 1, 2, 3, 4. So if you count everything, it's going to be 5. 1, 2, 3, 4, 5. Are you there? For the D, we draw 5 boxes. For the D, we draw 5 boxes. Whereby for the F orbital, how many boxes do we draw? We draw 7 boxes. 1, 2, 3, 4, 5, 6. If you count, we draw 7 for the F, but there are reasons. But I have to just, okay, I don't want to talk about it. I don't have to be telling you things that you don't know the reason why. You just be telling me, no. Let's just stop here. But all these things I just said, there are reasons. Go and learn to my video lesson on quantum number. And also for students here, you are still having difficulties understanding stoichiometry, chemical equilibrium, chemical bonding. These 3 topics. There are other things I've taught on my channel, many other topics. But I know that these 3 topics give students a lot of problem. So make sure you go watch these videos on my channel to understand them very well. You understand? But let's solve this question. How do we get the number of unpaired electrons or paired electrons in an atom? They've given us the information already, so let's get it. And the first rule I give to us is to look at the last orbital. Is to what? Look at the last orbital. The last orbital here is 2p3 orbital. So when you see that orbital, bring it out. You write it as 2p3, you bring it out. And you know it's p now, so for the p orbital, how many boxes do we draw? We draw 3 boxes. I've explained that already. But for we to get this, there is a reason. But just note it for the sake of solving questions like this in the Jamb exam. So then, there is another man that talks about how we can fill, because these are boxes. They are boxes. Alright, just wait. They are boxes. Each of those boxes carries a maximum of 2 electrons. Each of those boxes carries a maximum of 2 electrons. And these electrons are signified or symbolized with lines. Relax. So then what we do next? According to this man called Horn's, he brought a rule called Horn's rule of maximum multiplicity. He said that for we to start filling electrons into these boxes, we should fill the electrons singly first. We should fill the electrons 1, 1 first, you understand? And how do we get these electrons? From our orbital, the powers are literally the electrons. The powers, all those ones raised to the power, they are literally the electrons. And in total here, we have 3 of it. So let's fill it singly first. 1, 2, and 3. Do you understand? We filled the 3 electrons this guy had into the boxes, and we've exhausted all of them. There's no other one to continue to fill. Let's say, for instance, it was 4 electrons. Then I will not continue from the first one again, and the electron will not come down. You understand? First I brought them up. For to not continue with the other one, it's supposed to be down. You understand? But now, because since it's 3 electrons, I will stop here. And I believe you know what unpaired is. Unpaired. This is a pair of marker because it's made up of 2. But if it's unpaired, it just be 1. Do you understand what I'm saying? So then, what happens then? So looking at all of these things, how many unpaired electrons can we all see? 3 unpaired electrons. So from this question, how many unpaired electrons does this element has with this electronic configuration? How many? 3 unpaired electrons. 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 Class, is it clear? 3 unpaired electrons. 3 unpaired electrons. 3 unpaired electrons. So that is for that. I believe you guys are following. It's very simple. Okay, so that is for that. So let's progress. Hope you guys understood what I said. Hope you guys understood what I said here. So let me give you guys your own question. Let's see how far you understood all these things. I want to wipe. So then this is another electronic configuration. You tell me the numbers of unpaired electron here. Here is 1s2, 2s2, 2p5. You have to be smart. It's still the last one. Draw your three boxes. Draw your boxes, three boxes. You understand for P now, and it's 2p5. So you fill single phase. You have 5 electrons. Fill single phase. 1, 2, 3, and it's not yet done. 4 and 5. So how many unpaired, class? How many unpaired? 1 unpaired. Is this clear? 1 unpaired. Class, is this clear? 1 unpaired. Look at it very well now. Is this clear? Let me know in the comments. Is this clear? Guys, make sure you give this video a like. 1 unpaired. Class, you can see what's happening. You can see what is happening here. Make sure you like this video, guys. Make sure you share this video, share these links to your friends. Share these links to your friends, alright? So now, you can see, now, it's still the way we got unpaired. That's how we should get paired. You understand? So from this same information, how many paired electrons are we having? How many paired? How many paired? 2 paired electrons. Hope you guys understood what I said now. Hope you guys understood now. For this same guy, how many paired electrons are we having? 1 pair and 2 paired. You understand? So we have 2 paired or electrons. 2 paired of electrons. So that's how it is. You get, that's how it is. So let me wipe. Now there's something very key I have to tell us as well. There's something very key I have to tell us. You must be aware that atoms or elements that possesses unpaired electrons, atoms of element that possesses unpaired electrons, they are paramagnetic. Atom that possesses unpaired electrons, what are they? They are what? Paramagnetic. You should note this. You should note this thing. They are very, very important. The Jamb exam can just ask you, all right, so since you know that, okay, you know how to calculate for the unpaired electrons now. So those atoms that have unpaired electrons, what are they called? They are paramagnetic. Note it, whereby those atoms that have paired electrons, that possesses paired electrons, these guys, they are diamagnetic. They are not paramagnetic, but rather they are diamagnetic. They are what? 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 Diamagnetic. Now, we also have another terminology. That one is ferromagnetism. Ferromagnetism is seen in a special types of atoms called transition metals. You know, transition metals are part of the periodic table, but I'm not talking about the periodic table right now. So I don't really, but I will still solve questions pertaining to the periodic table because there are many questions that can come from these information we are passing out, and that is what I'll be solving now. So the next question now will be based on we knowing how, because Jamb exam also asks it, they'll give you an atom, they'll say what group does it belong to, what period does it belong to in the periodic table. Remember, the periodic table has, you know, about 8 groups, you understand, and so many other periods. You get 8 and so many other periods. But you should just know that we have group 1 element, group 2 element, group 3, group 4, group 5, group 6, group 7, and group 8. Remember, group 1 elements, they are called alkali metals. The Jamb exam can ask you, what are group 1 elements called? What will you say? Alkali metals. What are group 2 elements called? Alkali earth metals. What are group 3 elements called? They are called earth metals. What are group 4 elements called? They are called the carbon family. What are group 5 elements called? They are called nitrogens. It's spelled P-nitrogen. The P is silent, so it's called nitrogens. What are group 6 elements called? They are called chalcogens. What are group 7 elements called? They are called halogens. What are group 8 elements called, or group O elements called? They are called noble gases or rare gases or inert gases. From all this I'm saying, they are gases that don't like reacting. You understand? They are stable. They have complete octet and duplex configuration. Go watch it on my video lesson on chemical bonding. I've explained the clear view about what I'm just saying right now. You understand? On chemical bonding, you get on chemical what? Bonding. So class, let me quickly talk about what I want to talk about now. On we understanding properly how to determine the group and periods of elements in the periodic table. Now, just relax, Look at how it works. Look at how it works. Look at how it works. So for instance, they gave us an atom is unknown X, and here is 23, and here is 11. And the question says, what group does this atom belong to? What group does it belong to? And as well as what period does it belong to? Very simple. You know, I told you that the periodic table is divided into groups and periods, right? By 8 groups and so many other periods. So how do we not just get the group and period? It's very simple. Remember, for we to get group and period, first of all, my advice, quickly write the electronic configuration of the element. You understand? So you look at this element now, you can simply quickly calculate for the pen for it. The proton is 11. We've talked about this many times. Proton number is what is down. Your electron number now is a neutral atom. There's no plus or minus here. There's no charge. Then proton equals electron. So electron is 11. And neutron is what is up minus what is down. 23 minus 11. And that is what? 12. You get. So now, what do we do next? And what did I tell us about electron number? Is the electron number we use to write what? Electronic configuration. Because it is from our electronic configuration we get the group and period of elements. It is from our electronic configuration we get the group and period of an element. It's from our electronic configuration we get the groups and period of elements. You understand? So let's quickly write the electronic configuration based on electron number being 11. So we'll start with 1s. So 1s, you know, the s orbital occupies a maximum number of 2 electrons. So it's 1s2 you get now. So the next is 2s. So 2s2. What's the next? 2p. You understand this thing? We've said this thing many times. 2p6. And lastly, 3s. And lastly, 3s1. Hope you guys are aware now. Hope you guys know this thing I just did. Oh. We got, if you count 2 plus 2 plus 6 plus 1, that's 11. Hope you guys understood perfectly what just happened. So then, for you to get your group and period, my advice is this. Look at the electronic configuration you've written and pick out the one with the highest energy level. Pick out the orbital with the highest energy level. Relax, I will explain. Guys, this is what I mean. Look at the orbital. Look at the orbitals. There's S, there's S, there's P, and another X. So pick out the one with the highest energy level. How will you know the one with the highest energy level? Very simple. The one with the highest number standing in front of an orbital is the highest energy level. So the one with the highest energy level is 3s1 orbital. Class, are you there? It is the number standing in front of the orbital that tells us the one with the highest energy level. So this is the one with the highest energy level. Very simple. Now, this is how you get your group and period. The number standing up, the power gives us our group. The power tells us our group. Whereby the number that is standing in front of the orbital tells us the period of the element. So then, this element that is unknown now, what group does it belong to? Group 1. And what period? Period 3. This is the answer to the question. It is very simple. It is not difficult at all. I believe it is clear. Let me know in the comment section. Let me know in the comment section. And also make sure you like this video, share this video with your friends. Group 1, period 3. 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 4. And this element is actually sodium, I know. It is sodium, but you don't have to just leave it alone, even if you cannot identify the element. Insofar you get the group correctly. That's the most important thing. I'll give us more questions in practice. You will learn them. They are all simple. So I believe I can wipe this. I believe I can wipe this now. I can wipe this now, right? I can wipe this. So now, this time around, we will not be writing. I will just be giving the electronic configuration from my head. And then let's say we have in 1s2, 2s2, 2p6, 3s2, and then 3p, let's say 3p4. No, let me just relax them. 3s. Oh my god. Okay, 3p 6 and 4s2. Everybody, look at this question. Look at this question. Look at it on the board. Look at this question on the board. It's simple. First of all, get your group and period from this electronic configuration information. What did I tell you guys? Pick out the one with the highest energy level. This one with the highest energy level. Because it has the highest number 4. You understand? So it's actually 4s2. Do you get? So then the power tells you your group, whereby the number standing in front of the orbital tells you your period. So these elements now belongs to group 2, period 4. Group 2, period 4. I believe it is clear, everybody. Is it clear? Is it clear? Is it clear? Is it clear? Let me know in the comment. Is it clear? Is it clear? Is it clear? Is it clear? Let me know in the comments. Let me know in the comments. So we'll now solve another one that looks that I don't want you to get confused at all. We'll solve one that I don't want you to get confused at all. Alright, so now what do we do next? This one I want you guys to be very careful about. I want to wipe the board. This will be the last thing for tonight. I'm already getting tired. I'm very tired right now. This is the last thing I'll be doing tonight. So then, this one, I'll solve 2 questions on these. So 1s2, 2s2, 2p6. I know you are aware about how these things are, but that's why I'm not really talking about it again. I'm just giving you, here is 3s2 and 3p, let's say 4. Alright, and this is electronic configuration. Question says, get the group and as well get the period. Now class, when we come across question like this, you have to be very careful. What was the rule? Pick out the one with the highest energy level. Pick out the one with the highest energy level. Pick out the one that has the highest number. If you observe, we have 2 guys with the same number, so you bring them down. Before it was just one number that is bigger than every other thing, but this time around they have the same number. Bring them down with this. So it's 3s2 and 3p4. Do you understand? And what did I tell you? It is your power. It is the thing up that tells your group. It is the thing up that tells your group. So then this thing I will note them, and it is 2 and 4. Then I'll just come and add them together. 2 plus 4, what's that? 6. 2 plus 4, what's that? 6. So then you tell me, oh, these elements should be in group 6. Do you understand? And what period is still period 3? Do you understand, class? Period 3. Class, is it clear? It is very, very simple. It is very, very simple. It is very, very simple. It is very, very simple, guys. Do you understand what just happened? Even if you have to say like you have same number for a lot of what do you call it? You have same number for a lot of electronic configuration. Pick them down, bring them down. You'll be able to get it without stress, guys. You'll be able to get it without stress, guys. I'm going to take it again one more time. So then, when they gave the electronic configuration, and you now found out that, okay, I told you pick the one with the highest energy level. And how do you get the highest energy level? It's number standing in front of them. Remember, in the previous examples, it's just one number that was bigger. Let's say we have 4 here and the rest was smaller. So we just pick only that one. But in this case now, the 2 biggest number are 3s2 and 3p4. You bring them down. The numbers on top, that's what you add. Normally it's the power that gives you. But now, since there are 2 sets of numbers, add your numbers. Is that clear? Add them, you get group 6. And then your period is still based on what is standing in front of them. And it is always identical. Do you understand? It is always identical. So the period is period 3. Class, is it clear now? Is it clear now? Because this is the last thing I'll be doing tonight. Alright, so we are done for now. God bless you all. I wish you all success. For those preparing to writing the first day, for those writing the first day and more other days in the Jamb exam, God bless you all. I might be here tomorrow as well for another live, so let's see how it goes. You get. Well, for those finding difficult to learn how to solve questions on stoichiometry, chemical equilibrium, chemical bonding, make sure you go watch them out on my channel. Alright, make sure you go watch them out on my channel. For the live, I don't know when I'll come. Alright, so that is for that, guys. We are done for now. Alright, guys. So see you guys when I see you guys. God bless you all.